Hello, everyone. Welcome back to One Run Academy. If you've been following along, you know we're deep into our series where I walk you through questions from a specially designed exam that mimics the ISTQB mobile application testing certification. We've carefully crafted these questions to match the real exam's topic distribution, language style, and difficulty level. Today, we're tackling the final set of questions in this series, questions 31 through 40. So, if you're preparing for the ISTQB exam or just looking to sharpen your mobile app testing skills, you're in the right place. All right, let's get started with question number 31. And as always, let's read the question together. Regarding the test process in mobile app testing, which of the following options represents the most true statement? A. Mobile analytics data are extensively used during the test implementation activity. B. The test process of mobile apps are exactly the same as the test process for desktop applications. C. Field testing scenarios are prepared during the test analysis and design activity. D. Analyzing store approval criteria and creating their validation checklists takes place during test planning activity. Okay, a true and false question. This one should be easy, and let's dive into analyzing the question and its options. So when we talk about the test process in mobile app testing, we're referring to the entire life cycle of testing activities, from planning and analysis to execution and evaluation, specifically tailored to the unique challenges of mobile environments. Now, let's examine each option to see which statement is the most accurate. Starting with option A. This one sounds like an incorrect one. This is because the test implementation activity is where we set up the test environment and prepare to begin test execution. By this stage, the analysis of mobile analytics should already have fed the planning phase. Therefore, stating that mobile analytics are extensively used during test implementation is misleading. Moving to option B. I believe it's crucial to recognize that the test process for mobile apps is not the same as for desktop applications. Mobile testing must account for factors like device fragmentation, network variability, battery usage, and user interaction in different contexts, making it distinct from desktop testing. So this statement oversimplifies the unique challenges posed by mobile testing, and is of course not the correct answer we're looking for. Next is option C. I think this one is a very strong contender to be the correct answer to this question. This is because during the test analysis and design phases, we develop scenarios that simulate real-world usage, including those specific to field testing. This is where we determine what needs to be tested and how to test it, ensuring that our tests cover all relevant conditions, including those that users will experience outside of a controlled environment. So let's keep option C in mind, and let's move to option D, which says analyzing store approval criteria and creating their validation checklists takes place during test planning activity. This is definitely not true. The analysis of store approval criteria and the creation of validation checklists typically occur during the test analysis and design phase, not during test planning. During planning, we focus on defining the testing strategy, resources, and timeline, while the analysis and design phase is where we dive into the specifics of what needs to be tested, including compliance with App Store guidelines. Very well. So, the correct answer is option C. Field testing scenarios are prepared during the test analysis and design activity. This statement is the most accurate because it correctly places the preparation of field testing scenarios within the test analysis and design phase, where we develop specific test cases and scenarios based on the requirements and objectives. All right, I believe it's time for us to encounter question number 32. So let's quickly do that. Your team is under significant time pressure, and you are suggesting the use of mobile emulators instead of mobile test devices in some testing tasks to speed up the testing process. Which of the following tasks is the most appropriate for applying this approach? A. Using emulators for field testing, especially for late development stages. B. Using emulators for unit testing, especially in early development stages. C. Using emulators for functional testing, especially in early development stages. D. Using emulators for store approval testing prior to the mobile app release. Very well. So, you and your team are working under significant time pressure and struggling to meet the deadline. And to help speed up the testing process, you're considering using mobile emulators instead of actual mobile devices for some of the testing tasks. The key question here is, which task is the most appropriate for using emulators? Now, let's go through each option to understand why it might be correct or incorrect. Starting with option A, using emulators for field testing, especially for late development stages. Okay, so this is not correct. Field testing involves testing the app in real-world environments to see how it performs under actual conditions, like varying network speeds, GPS accuracy, and real-world user behavior. Emulators, while useful, can't replicate these real-world conditions accurately. They're best for controlled, predictable environments, but fall short when you need to mimic what happens outside in the real world, especially in the late stages of development, when testing needs to be as close to reality as possible. Next, option B, using emulators for unit testing, especially in early development stages. This one is also not correct. Unit testing typically involves testing individual pieces of code or small components of the app in isolation. This is usually done using specific tools like IDEs or unit testing frameworks rather than emulators. All right, let's look at option C, which suggests using emulators for functional testing, especially in the early stages of development. This could actually be the correct choice. Functional testing focuses on making sure that the app's features work as intended. During the early stages, emulators are highly valuable because they allow you to quickly test core functionalities. Additionally, at these early stages, it might not even be possible to install the app on a real device. In such cases, emulators can be a great solution. And finally, it's time for option D, which should be incorrect. And indeed, it's not correct. Store approval testing involves ensuring that the app meets all the requirements set by the App Store platforms, like Apple's App Store or Google Play. These platforms often have strict guidelines that require the app to be tested on actual devices to make sure it performs well under real conditions. Emulators simply cannot replicate every fine distinction of a real device, especially when it comes to performance, battery usage, and hardware integration. So, to sum up, option C is the most appropriate use of emulators when your team is under time pressure, especially for functional testing in the early stages of development. This approach allows you to quickly and efficiently validate the core functionalities of your app, laying a strong foundation for the more detailed and device-specific testing that will follow. Moving next toward question number 33, which says, among the following roles involved in the mobile SDLC, who is the least likely to use an IDE during the development process? 4 options are always provided. A. Security tester. B. User acceptance tester. C. UI designer. D. Mobile app developer. Very well. Let's start by understanding the overall question to ensure we're all on the same ground. The question here is asking us to determine which role in the mobile software development lifecycle is least likely to use an integrated development environment, or IDE, during the development process. We need to figure out who among the listed roles would have the least need to interact with an IDE. Now, let's break down each of the options and evaluate whether each role is likely to use an IDE or not. Starting with option A. I believe security testers might use an IDE as part of their workflow. They often integrate automated security testing tools within the development environment, review source code, and run static analysis to identify vulnerabilities. Although their primary role isn't writing code, the tools they use are frequently tied into an IDE to make the testing process more efficient. They may also collaborate with developers in resolving security issues directly within the IDE. So, security testers actually do need IDEs and use them frequently. Moving to option B, user acceptance testers. This one is pretty much the answer we're looking for. They are the least likely to use an IDE because their focus is not on code, but on verifying that the app meets user and business needs. Their main task is to test a fully developed or nearly finished app to ensure it works as expected from the end user's perspective. They typically conduct manual testing using real devices in real-world scenarios and don't need direct access to the development tools or environments where the code is created. Since their work is closer to the user experience rather than technical development, they have no need for an IDE. So, this option is a very strong candidate to be the correct answer to this question. Let's move on. Now, option C is clearly not correct. UI designers often work closely with the app's front-end elements and may need to use an IDE to design, prototype, or implement user interface components that will interact with the app's code. Although they may also use design-specific tools like Figma or Sketch, they are still involved in the development side enough to potentially use an IDE for fine-tuning how the UI elements integrate with the app. Finally, option D. No doubt that mobile app developers are the primary users of IDEs. They rely heavily on IDEs to write, test, and debug the code that builds the app. The IDE provides them with essential tools for coding, compiling, and running the application on various devices or emulators. In fact, an IDE is one of the most critical tools for developers throughout the entire mobile development process. So to sum it up, option B, user acceptance tester, is the correct answer. They are least likely to use an IDE, as their focus is on real device testing and verifying user satisfaction, not on the technical development tasks that require an IDE. Very well. I believe the upcoming question is question number 34. So let's see what's all about. As an iOS mobile app tester, you want to evaluate how much device memory and CPU a certain app consumes. Which of the following tools is the best to help you accomplish this task? A. Instruments. B. ADB. C. Android Studio. D. Test automation tool. Great. So in this question, we are tasked with figuring out the best tool for monitoring CPU and memory usage on an iOS mobile app. The question is very specific. It's about iOS, and the focus is on monitoring the app resource consumption. So you're looking for a tool that helps you track how much iOS device memory and CPU the app consumes. Keep this in mind as we review the options. Starting with option A, Instruments. Instruments is a performance analysis and testing tool built specially to monitor Apple apps, including iOS, macOS, iPadOS, and so on. It allows you to collect and analyze data in real time, making it the best fit for this task. So Instruments is what we're looking for in this case, I believe. Moving to option B, which is ADB. Knowing what ADB stands for is key here. ADB stands for Android Debug Bridge, which by common sense deals with Android, not iOS. Next is option C, Android Studio. Also, as the name implies, this is not what we're looking for. And lastly, option D, Test Automation Tool. This option is also not correct. Test automation tools are generally not used for performance monitoring. If you're focusing on metrics like CPU or memory consumption, you would need a specialized tool like Instruments, not a generic automation tool. All right, so the best tool for this task is Instruments. That's option A. It's designed for iOS performance monitoring and allows you to monitor things like memory and CPU usage, which makes it the most appropriate choice. Very well. Let's encounter question number 35. Which of the following statements is the least accurate about the differences between mobile app simulators and emulators? A. Emulators provide a closer representation of how the app would behave on a real device. B. Applications running on an emulator generally run slower compared to those running on a simulator. C. Both simulators and emulators help reduce the costs of mobile app development and testing. D. Simulators run the same bytecode version of the app that would be used on a real device. Okay, so we're being asked to identify the least accurate statement about the differences between mobile app simulators and emulators. This is a comparison question, so it's important to understand the main differences between simulators and emulators in the context of mobile app testing, of course. Both are used to test apps, but they function differently and serve different purposes. Your job here is to figure out which statement is the least true, or in other words, the most incorrect. Starting with option A, emulators provide a closer representation of how the app would behave on a real device. Well, emulators are designed to mimic both the software and hardware environments of a real mobile device. Because of this, they provide a more accurate reflection of how the app will behave on an actual device. Simulators, on the other hand, only replicate the software environment, meaning they are less precise in mimicking real-world conditions. So, I guess option A is an accurate statement. And since we're trying to find the least accurate statement, this makes it not the answer we're looking for. Moving to option B, applications running on an emulator generally run slower compared to those running on a simulator. Again, this one is an accurate statement. You see, emulators have to simulate the entire mobile device, including its hardware, which means that not all the computer CPU will be available for the emulator. As a result, apps tend to run slower on emulators, because theoretically, most test computers are equipped with a super fast CPUs compared to what we find on most mobile devices. Simulators, on the other hand, do not simulate hardware and can utilize the full processing power of the computer they are running on, making them faster, of course. Next is option C. Both simulators and emulators help reduce the costs of mobile app development and testing. This is, of course, very true. Both simulators and emulators are used to test mobile apps without needing a physical device. This reduces the cost of testing, especially in the early development stages, when you might not have access to a wide range of real devices. Now we're left with option D, which should represent an inaccurate statement. Option D says, simulators run the same bytecode version of the app that would be used on a real device. Finally, an incorrect statement. Simulators do not run the same bytecode as what would be used on a real device. When you run an app on a simulator, it's compiled in a special version that works in the simulator's environment, but it wouldn't run on an actual mobile device. This is a key difference between simulators and emulators. So the least accurate statement is option D, because simulators don't use the same bytecode as real devices, which means they aren't as close to real-world conditions as emulators. All right, we've made it halfway through this lecture. Awesome. Great job sticking with it so far. If you're still with us, don't forget to give this video a thumbs up to show your support. And if you haven't yet, be sure to subscribe to One Run Academy on YouTube and follow us on LinkedIn for more updates. Now, let's dive into question number 36 and keep the momentum going. After the release of the iPhone 16 Pro Max, you need to test your existing social media app's integration with the new camera button and ensure the app can capture photos and videos using this feature. Given your limited test budget, what is the best approach to fully test the app's compatibility with the new camera button? Very well. Let's dive into this question. The scenario you're dealing with here involves a budget-limited situation where you need to test your social media app's integration with the new iPhone 16 Pro Max camera button. Your goal is to find the best approach to fully test the app's compatibility with this new feature without overspending. Now, let's take a look at the available options. A. Purchase the iPhone 16 Pro Max and add it to your existing on-premise test lab's device collection. B. Rent time with a remote test lab that includes the iPhone 16 Pro Max in its device list for testing. C. Use an iPhone 16 Pro Max emulator to simulate the new feature and test your app's functionality. D. outsource the testing to an external company that specializes in iPhone 16 testing. All right, let's discuss each option and see which of them better matches our current context. Starting with option A. This option suggests buying the new iPhone 16 Pro Max and adding it to your existing on-premise test lab. Now, having the device in-house might sound like a great idea because it gives you direct access to test all the features hands-on. But given your budget constraints, this is not the best option. iPhones are expensive, and the iPhone 16 Pro Max starts from $1,200. So, unless you plan to extensively test on this device over a long period, purchasing it just for a few tests might not be a wise use of your budget. So, this is not the most cost-effective approach. Moving to option B, I believe this is the best option. By renting time in a remote test lab, you can access the iPhone 16 Pro Max without having to buy the device yourself. Remote labs offer real device testing, meaning you'll be able to accurately test how the app integrates with the new camera button. Plus, it's a cost-effective solution, especially when you're dealing with a limited budget. You only pay for the time you need, and you can still test on the actual hardware. This approach strikes the right balance between cost and testing accuracy. Now, option C, using emulators. While emulators can be useful in testing certain aspects of an app, they cannot replicate hardware features like a camera button. Emulators simulate software environments, but don't have access to real hardware like cameras or sensors. This means that while you might be able to test some basic functionalities, you won't be able to fully test the camera button integration with your app. Since the question is about testing a specific hardware feature, this option wouldn't give you the accurate results you need. So, this is not the right approach for this situation. Lastly, option D is about outsourcing the testing services. I believe outsourcing the testing to a specialized external company might seem like a good idea if you need expertise, but for this specific task, it's probably overkill. Outsourcing can also be more expensive, which is a problem given your limited budget. You also lose some control over the testing process, which might not be ideal if you want to quickly adjust and retest certain features. So this is not the most efficient approach for your situation. So, the best approach here is option B, renting time with a remote test lab. This allows you to test your app's compatibility with the iPhone 16 Pro Max camera button on a real device while keeping costs low. All right, now is the time for question number 37. Let's read it together. As a mobile test manager, you are considering introducing a new test automation tool to replace the old one. Many options are available to pick from. Which of the following features is the least valuable when selecting a new mobile test automation tool? A. Having good and well-explained documentation. B. Features video recording of the test execution. C. Can integrate performance testing tools. D. Compatibility with different SDLC models. Cool. So you are a mobile test manager, and your team is looking to replace an old test automation tool. Now you have several new tools to choose from, but the question asks you to determine which feature is the least valuable when selecting a new mobile test automation tool. This means we need to focus on identifying the feature that offers the least amount of benefit in comparison to the others. Fair enough. Let's analyze each option. Option A, having good documentation. Documentation is critical for any test automation tool. If a tool has clear and thorough documentation, it makes the tool much easier to adopt and use by your team. Well-explained documentation helps reduce learning curves, making it easier to onboard new testers and helping your team troubleshoot problems faster, which makes the overall test process more efficient. For these reasons, this feature is very valuable and should be a priority when selecting a tool. So this option is not the correct answer since we're looking for the least beneficial feature. Now, video recording of test execution might sound useful. That's option B, but it's actually not a crucial feature for most testing scenarios. After all, the goal of test automation is to run tests efficiently and analyze the results. The most important information comes from the text reports and logs generated by the tool, which testers can quickly review and analyze. Watching a video of every test run could take up too much time, and storing large video files adds unnecessary overhead. This makes video recording represent an option that could be the least valuable feature in comparison to others. So let's put this option in mind as a possible answer to this question. Next, option C, integration capabilities. I think it is highly valuable. If a test automation tool can integrate with different other tools, such as continuous integration tools, performance test tools, and so on, it means you can extend its use beyond basic functional testing. Being able to do so is a feature that is important when selecting a tool. So I believe we can exclude it from the list of possible answers. Lastly, option D, compatibility with different SDLC models. This is also crucial. Whether your team follows Agile, Waterfall, or any other methodology, a tool that can adapt to various models helps ensure that automation fits seamlessly into the development process. A flexible tool that can work in different environments is always a plus, making this feature highly valuable. Looks like we have a winner. That's option B. This is the least valuable feature in this case, as video recording of the test execution doesn't offer as much value as the other features when selecting a new test automation tool. Now, let's quickly encounter question number 38, and it says, after introducing a new OCR automation tool, the mobile developer noticed that test case execution was taking longer than when using the previous tool, which relied on object identification. As a software tester, how would you best explain the reason for this slowdown to the developer? Great. In this scenario, you're dealing with a situation where the new OCR automation tool is causing longer test execution times compared to the previous tool, which was based on object identification. The developer has noticed the slowdown, and as a tester, your job is to explain why the tests are now running slower. The goal here is to identify the most accurate technical explanation for this slowdown from the following options. A. Writing scripts for OCR tools takes more time compared to object identification tools. B. OCR tools are generally slower because the object ID changes with each test run. C. The issue is likely due to problems with the test machine, not the automation tool. D. OCR tools compare the screen to a base image pixel by pixel, which is a time-consuming process. Okay, option A is instantly identified as not correct. This is because the question is focusing on test execution time, not the time spent writing scripts. So this option can be ruled out. Moving to option B, which is a misleading statement. OCR tools do not work by identifying object IDs at all. Instead, OCR tools rely on analyzing the visual content on the screen, meaning they compare images and text, not object IDs. And since object IDs don't play a role in how OCR tools function, this explanation is inaccurate. As for option C, I believe that test machine issues can cause slowdowns. However, there is no indication in the question that suggests the problem is with the test machine itself. The key point here is that the slowdown occurred after introducing the new OCR tool, which suggests the issue is related to the tool's functionality rather than the hardware. So, this option is not the right explanation. Lastly, we reach option D, which is indeed the correct explanation. OCR tools work by scanning the screen and performing a pixel-by-pixel comparison against a predefined base image. This process is way more computationally intensive compared to object identification tools, which use unique identifiers to find elements on the screen directly and quickly. The pixel-by-pixel analysis is why the test execution is slower when using OCR. So, this is the right answer. This provides the developer with a clear and accurate technical reason for the performance difference, helping them understand the core issue. Thank you, Mr. Tester. You are officially the pixel detective, solving slow performance cases one pixel at a time. Sherlock Holmes would be proud. Now, let's encounter question number 39, which says, Which of the following factors is considered the most technical when selecting a tool for mobile app automation? A. The training required for developers and testers to effectively use the mobile automation tool. B. Estimating the cost-benefit ratio of using the tool in long-term mobile projects. C. The tool's ability to run tests on multiple mobile devices simultaneously. D. Assessing the organization's readiness and maturity for adopting mobile test automation tools. Very well, a very direct and straightforward question here. You are asked to identify the most technical factor when choosing a tool for mobile app automation. The focus here is on selecting a feature or aspect that is specifically related to the technical capabilities of the tool itself, rather than any other organizational or business considerations. Looking at option A, we can see that it's referring to an organizational factor. Yes, training is essential for using the tool efficiently. However, it doesn't directly reflect the technical functionality or performance of the tool itself. So this option is not a technical factor. Moving to option B. This is also not correct because it focuses on the financial and strategic planning involved in using the tool over a long period of time. The cost-benefit ratio is important for decision-making, but it is an organizational factor, not a technical one. Next is option C. I believe it addresses a specific technical feature of the automation tool. The ability to run tests on multiple devices at the same time is a key technical capability that directly impacts the tool's performance, scalability, and efficiency. This feature ensures that the tool can handle parallel test executions, which is crucial for mobile testing environments, where testing across many devices is often necessary. So this is the most technical factor, at least for now. Lastly, option D, which we know already that it's not correct. This is another organizational factor. The company's readiness and maturity refer to whether the organization has the necessary infrastructure, processes, and culture in place to support the introduction of mobile test automation tools. It doesn't reflect the technical capabilities of the tool itself. So, this is not a technical factor. So the most technical factor when selecting a tool for mobile app automation is option C. The tool's ability to run tests on multiple mobile devices simultaneously. This directly addresses the tool's technical capabilities and how well it can scale and perform in a mobile testing environment. At last, we've made it to question number 40. It's been quite the journey, but I truly believe that your ISTQB mobile application testing exam preparation is now on a whole new level. So, congratulations for sticking with it and pushing forward. Now, if you're feeling like you want more practice or a little extra challenge, I've got you covered. I highly recommend checking out our ISTQB mobile application testing exam preparation course on Udemy. You'll find 6 additional full-length exams designed to mirror the official test in every detail, from topic distribution to difficulty level, and even the way the questions are phrased. Just hit the links in the description to explore the course. Now, let's take a look at question number 40, which says, which of the following scenarios represents the most mandatory case for using remote automated test labs? A. A video streaming mobile app that needs to be tested across a large number of devices and OS versions before it's released to the App Store. B. A social media app in the early stages of the software development lifecycle, where automated regression testing is planned. C. A banking app in its final stages of development that requires testing on a wide range of devices and OS versions. D. A video game app in its early stages of development that needs multiple touch and accelerometer validations. Very well. So you're being asked to identify the most mandatory case for using remote automated test labs over something like on-premise labs. The focus here is on which scenario truly requires the features and advantages of remote test labs. So that's something to put in mind when attempting to answer this question. From this point, we can start analyzing each option to see which of them fits the question's context. Looking at option A, a video streaming mobile app that needs to be tested across a large number of devices and OS versions before its release to the App Store. I believe testing a video streaming app across many devices and OS versions is a classic use case for remote automated test labs, especially if we're talking about the final stages just before the app release, as it's crucial to ensure that it functions smoothly across a wide variety of real devices. Remote labs provide access to a large pool of devices without the need for purchasing or maintaining them, making it the most practical and efficient solution for running all your scripted tests with a click of a button to make sure everything is okay. So, let's keep option A in mind as a very strong candidate to be the correct answer to this question. Next, let's take a look at option B, a social media app in the early stages of the software development lifecycle where automated regression testing is planned. Obviously, this is not correct because the app is still in the early stages of development, and typically, at this point, the focus is more on functionality than on testing across multiple devices and OS versions. Automated regression testing is important, but in the early stages, it can often be done using a limited set of devices or emulators locally, rather than requiring access to a full remote test lab. There's no urgent need for remote testing here. Now, option C states that a banking app in its final stages of development that requires testing on a wide range of devices and OS versions is a good reason why we should go with remote automation labs. I would say no to that, as banking apps involve sensitive data and strict security requirements. Imagine testing the app by logging into a bank account and making money transfers and other account operations on a device that is not in your hands. Sounds way, way far from best security practices. The solution? You should go with on-premise labs. They are typically preferred over remote labs to ensure greater security and control over the testing environment. Security concerns make remote labs less suitable here. Now, for the final option, option D, a video game app in its early stages of development that needs multiple touch and accelerometer validations. Again, this option is not correct because the app is still in the early stages of development. Plus, touch and accelerometer validations are better performed on local physical devices, as remote automated test labs may not be the best choice for complex physical interactions like multiple touch inputs or accelerometer validations, as these require direct interaction with the device. Local device testing is more appropriate at this stage, so it is very evident that option A is the correct answer. This scenario demands extensive testing, which remote test labs can handle efficiently by providing access to a wide variety of real devices and operating systems. And with that, we've come to the end of our ISTQB CT MAT exam preparation series. I really hope you found it valuable and that it helped you feel even more prepared for the final test. You've done an awesome job making it through this, so give yourself a pat on the back. Good luck with your studies. Take care, and see you next time.